Good morning, everyone. You are welcome in AI with Rao, and let's make AI simple. So, in this journey of machine learning, I have come to the eighth day, and in eighth day, let's see what topics we are going to cover. So, this is why the model is a random forest. Go to the seventh day and understand uh, the forecast tree and the disadvantage it has overfitting and underfitting. This disadvantage is completely covered, and now you can say is completely gone through this model or algorithm that is called a random forest. It's pretty simple, I promise you. The second, how a forest of tree votes together, and clever trick that makes each tree different, and why the crowd is always right. Okay, so no suspense, let's start. The first line, the one liner, is one decision tree can be wrong. Here remember one thing, the tree I am saying now, just remember as a person. So one person can be wrong, but random forests ask hundreds of trees, means hundreds of persons same question and takes a vote. The crowd is almost always right. This is the whole idea. And as usual, we take an example, and that is the story. And the story is everyone's favorite, कौन बनेगा करोड़पति. In this, we have asked the audience question. When you are stuck with your answer, you can ask the audience poll you can take, and this is the whole algorithm. So what the people are doing, same we are copying in machines and solving these kinds of problem. You got it? It's as simple. So now let's dig deep into it and understand. The core idea is, see, first let me go through the real, and then we will understand the story and the real example. See, if we have one tree, a decision tree that we covered in day 7, it can go wrong. The reason, because of two disadvantages, overfitting and underfitting. But if we create a hundreds and thousands of such trees with different varieties, each of these trees are different from each other, they are independent, different, and we will put the same question to each tree, and on the consensus basis, which has the more number of vote, that will be the answer, and that will be the most logically correct answer, and always right most of the time. This is the whole idea. Now you come to this kaun banega crorepati. Okay, you got this example. Now this spam, the real is this tree versus whole forest. So one tree versus the whole forest. And in forest there is not only one type of tree. In forest there are many different varieties of trees. So you will ask one question to one tree and then ask the same question to each tree in the forest, and then let's see what happens. So we put this question that, hey tree, tell me, this mail is a spam or not? One tree says no, it is not a spam. Now we put the same mail and give the same question to all trees present in the forest. And now let's suppose very simple forest has this 2 to 4 to 6 and to 8 trees in the forest. Okay, now among that 6 says yes and 2 says no. Now you tell me, is this, which one you will trust, this one person or this 8 trees? Of course 8. And what is the consensus? That is yes. It means what? The email is a spam. You got this point? This is what, just like a vote of consensus. Now let's come to the real trick that we discussed in the beginning, that what makes it different. See, in the data set you can see right now we have all data, like full data and all clues. Every set is all data and all clues are there. What we are going to do is, we will not throw all data and all clues to each and every tree in the forest. No, we will give different variety, different number, some data, some clues, some data, some clues, different data, different clue. One tree, some rows and some clues. We will just distribute differently. We will give different amount of clues and different amount of data. Say 100 data is there and 100 clues are there. Then what we will do? We will give 20 data and 30 clue. Okay, 50 data, 20 clues, 70 data, 20 clues, like that. Distribute them differently, because then they will behave differently. Else what will happen? Everyone we will sing the same song, because they have the same set of data. Now you got the trick? Exactly. So this is what we are going to do. This is what I have explained and written here. And now the question is, why the crowd is always right? And here is the actual graph that quantitatively tells you that why crowd is almost always right. This is the y-axis accuracy, and this is the x-axis number of trees in the forest. Now one person is there and one tree is there. One tree is saying 78% of the time this is correct. Now we increases the number of trees in the forest and the accuracy increases, but after a certain point it becomes flattered. The reason, it's a very interesting one. So see, each tree is right slightly more often than the coin flip. Then a big group of them voting together become almost always right. More trees, fewer mistakes, until it flattens out. And that's why random forest is the favorite for real world problem like fraud detection, medical test, loan approval. You got the point? Now you have, like, the whole forest is working for you, not one tree. You got the answer? Now the formula is pretty simple. No fancy calculus, okay, no derivatives, just this comes from simple math. And what is it? Say if you have like votes, but every situation is not always you will get yes or no. Sometimes, say if you want to predict the price of a house, you will get a number. Then in this scenario what you will do? You will get each trees in the forest, their number, what they are saying, and the average it, and this will be the vote of all trees together in the forest. And then you can say what is the actual price. That will be most of the time correct one. Now let's train it, the model, how the training will happen. We have this random forest classifier. we took the model, and here is the real thing, that is an estimator. That is, we are taking 100 trees rather than relying on one tree. We are taking a group of 100 trees, okay, and then we passed what? Income, age and credit, okay, and then we are here this is very important one, feature importance. Here we can understand the trend, that which was the actual tree that was dominating, which nature, which pattern was dominating. We can print it and we can tell this to our boss that, sir, why we took this decision based on this pattern, and the clue that the whole most of the trees in the forest were following. You got the point? Now it's not always the best. There are some drawbacks, and the first is slower and bigger. If you have just yes, no, very simple situation, in that case, what is the need of training 100 trees and consuming 100 of like that much of memories and that much of time? Waste. Now harder to read. If you have one tree which has 5 questions, you can read the logic clearly, but similarly the whole forest have different varieties of tree, different sets of data. Reading hundreds and thousands and lakhs of tree, almost impossible. Now you got the point. And not for everything. This is a very important concept, and that leads to more interesting concept that we are going to follow throughout the journey of our AI engineering, that it doesn't work well for image, text, speech, and where it lacks, and at that point deep learning science. Now you got the seed of deep learning. What in the next series we are going to cover deep learning, and the seeds for deep learning is being planted here, okay. But the question is, where does this model science, tabular data, where we have a business data in table format, we have column and row, in these category of data, random forest, just boom, okay. Now at the end, let's discuss what we have done in this video. First, we understand the random forest, ask many tree and their vote. Wisdom of the crowd is almost every time right. Now one tree can be wrong, but forest votes out the mistake. What are the mistakes that has been done by one tree? And now the trick, each tree sees random rows and random clues, so that's the reason each of them are different. And we take, if it is yes and no, majority of the vote, and if it is a number, we will take the average. Nothing scary derivative and calculus, and it's science on tabular data and real world situation. So now the whole picture is very clear to you. Machine learning is really simple, okay. Just be there with me. I promise I will teach you machine learning in 30 days and you never ever regret it. Thank you so much for being in the video till now.